Alright, welcome to episode 4. Today we're going to be talking about falling objects. So when we first got assigned the project and I figured out how to do falling snow, one of the most requested things that people were asking about was, how did you make the snow fall? And here I am with a tutorial about a month later after the project was due. Anyway, here we're going to have a point. So the x value is 1, y value is, in this case, let's start it at 10. So first thing we do is we couldn't actually do snowflakes, so we just made it a blue x because, putting a snowflake equation, copy and pasting that about 8 times, translating all that, like that's just way too much work. So next thing we do is we add a slider for a. So what it does is that it takes the top y value and subtracts a. A can have a value of between 0 and 10. This is the maximum amount you want to subtract it by, and this is the minimum amount. So if you subtract 10 by 0, that means it starts at 10. If you subtract 10 by 10, that means it ends up at the bottom, right? Leave the step blank. And if you just let it run for now, you're going to notice that it bounces. So we simply flip it. Desmos sliders only have 2 states. It can only go left to right or switch back and forth. So if you ended up just writing A, it would end up going up. So you actually have to make it your top value minus A. And that way it's going to go down. So that's simply how you do falling objects. It applies to both, what's it called? It applies to points, but you can also just take any function, like let's say x squared, and then you want this function to decrease. Oops. Let's put x in brackets, and then you say subtract a. Same thing. It honestly works for any type of function you want, but in this case, we just wanted it to stick with these dots. Anyway, so the next thing people were asking about is, let's say you wanted to make it stop. So here's a simple rectangle. The y is between 0 and 4. X is between 0 and 8. That's how it's written. And let's say we wanted to stop at y is equal to 4. So the restriction, so long as a is less than or equal to 6. Because if 10, you want to make this equal to 4, right? 10 minus a is equal to 4. A then has to be 6. So if a is less than or equal to 6, let me copy paste it. And you want the y value to be 4. Let's make these look the same. And let's just flip around the restriction. So here it is. When it gets to 4, you'll notice that it stops. Thing is, you can't actually make something just stop in its tracks. This is another illusion similar to what we did with the blinking lights. It's not actually stopping the dot in its tracks. It's simply, it only draws the first equation so long as a is less than 6. And that's falling, it'll draw it. Once it's past 6, it disappears. And once it disappears, it gets replaced by this thing, which so long as a is greater than 6, this will show up. So it sort of like takes it out and then replaces it with an identical looking dot in the position it's supposed to be. And it gives a convincing enough illusion. The other thing you can do with these falling dots is, let's remove the restriction. You can make the x value a function. Let's say 0.5a. In this case, it's a linear function, moves down with a slope of 0.5. Obviously, since the y value is decreasing, it's a negative function, right? And then you can say, for instance, make it sine of a. And we actually did this for our assignment. We used a bunch of sine waves to make it look more natural. As it's a normal sine wave, you can do normal stuff to it, like you can stretch it out, right? You can make it thinner. You can increase or decrease the period if you wanted to. It's just a regular sine wave. You can do whatever you want to it. So what we had was we had a bunch of these. And then let's say you wanted to stop at y is equal to 5, let's say. So 10 minus 5 is 5. And we notice that the point is negative 0.959. Draw another one, negative 0.959, 5. and then let's make it like this. And let's give it the restriction so long as a is less than or equal to, not a is less than or equal to 5. Take it, reverse it. There we go. So here it's falling, and when it hits 5 it stops. With sine waves it's a bit more difficult because you actually have to find the spot. You get some really weird numbers, and then obviously if you like transform the sine wave you have to recalculate this exact position. It's kind of a pain, and we did that a few times. And yeah, that's basically how you do falling snow. We just had a bunch of these, made them start at like different positions so that they're kind of like non-synchronized, because if they all fell at the same time it'd be kind of like artificial looking, you know? And yeah, that's how you do falling objects. Hope that helps.